So if you are new to this topic, or you have learned it in school before but your teacher explained it in a way that you couldn't really understand, this will be the only video you will ever need. And without further ado, let's jump right in. So consider these two triangles over here, right? We call them similar. Both these two triangles are similar, but how do we really quantify or tell whether they are similar? It all comes down to two things. So for two triangles that are similar, they must fulfill these two conditions. So number one is the corresponding angles are equal. So I'm going to label the vertices now. A, B, C, D, E, F. This means that if triangle A, B, C is similar to triangle D, E, F. This means that angle ABC equals to angle DEF. Angle ACB equals to angle DFE. Angle BCA equals to angle EFA. All the corresponding angles are equal. Exactly the same. And now the second one would be the ratio of the corresponding sides are equal. Now, this is different from congruent triangles, where congruent triangles are corresponding sides are equal. For similar triangles, the ratio of the corresponding sides are equal, because for similar triangles, they are not the same, right? They are not the same size. This one is the so-called the shrinked version of ABC, right? DEF is the shrink version of ABC. But when you shrink DEF, all the sides of DEF will shrink by the same proportion, right? If you half the length of every side of DEF, you will get half of original ABC, and therefore the ratio of the corresponding sides are equal. This means that AB over DE equals to AC over DF equals to BC over EF. And if we were to plug the values, right, AB is 4 units, DE is 2 units, and then AC is 6 units, DF is 3 units, BC is 2 units, and the EF is 1 unit, which all makes sense because this is half equals to half equals to half. So the ratio of the corresponding sides, so all this is one corresponding side. This is a pair of corresponding sides. This is a pair of corresponding sides. And this is a pair of corresponding sides. So the ratio, which is this, and this, they are all equal. And that is the meaning of ratio or corresponding sides are equal. So this is how you quantify two triangles to be similar. That is, their corresponding angles are equal and the ratio of the corresponding sides are equal. So with that being said, there are 3 rules or 3 conditions to test that verify two triangles are similar. Just like congruence, there are 4 congruence tests. For similarity, there are 3 similarity tests, and they are respectively 1, 2, and 3. So the first one will be your AA similarity test. That means for 2 triangles, if they are similar, let me just redraw this. Okay, if 2 triangles are similar, that means this angle over here and this angle is the same, and this angle over here and this angle over here is the same. So if I were to label this A, B, C, D, E, F, that means if angle ABC equals to angle DEF and angle BAC equals to angle EDF, then triangles ABC and DEF are similar, and we call this the AA similarity test. On the other hand, we have another one called the SSS, Similarity Test. So consider these two triangles again. If this is A, B, C, this is D, E, F. So if AB over DE equals to BC over EF equals to CA over FD, then they are similar. Obviously, to prove this, you will need to find out the length of each and every single side over here. Then you can do your ratio comparison. And we'll call this SSS, Similarity Test. And then for the last one will be your SAS. So AA is one, SSS is another one, and then SAS is the last one. So if the question never specify, you can just choose either one of these to prove that the triangles are similar. So you have three weapons that you can use. Just use one of them depending on the context of the question. So this is similarity test. And this basically looks like this, right? If you have this triangle and then this triangle. So if they are similar, let's say we have this angle over here, that means this is A, B, C, this is D, E, F. That means if AB over DE equals to, let's say, AC over DF, and angle ABC equals to angle DEF, then and only then you can say that they are similar. And we will say that this is the SAS similarity test. So these are the three ways to prove that three triangles are similar, and this is the concept of which similar triangles are built upon. So I hope this video gave you a clear enough explanation as to what similar triangles are. If you'd like to get this exact note that I just created, as well as all of the other notes for all of the other videos on my channel, you can get yours today in the link in the description. If not, if you like more resources for math, you also can check out the other links that I have in the description. If not, there's a video that's going to appear on the right now for you to watch to get a better understanding on triangles. If not, that's all for me today. Thanks for watching. I will see you in the next video.